All right, we're going to look at the some of the chain rule problems we did in class, and we'll go ahead and start with a reminder of the general power rule. If u is a differentiable function of x, and n is a rational number, so that's all the positive and negative integers plus all the fractions, then if f of x is equal to u to the n, so remember u is some function of x, then if we take the derivative, we're going to have to use the chain rule. So it's going to be the derivative of the outside function. The outside function's the power to the n. So the n comes down, and then it becomes u to the n minus 1, subtract 1 from the exponent, and then times the derivative of the inside. So that's the chain rule. So let's take an example of f of x is equal to the cube root of x squared minus 4x minus 2. So this is a composition of functions. The outside function is cube root of x. The inside function is x squared minus 4x minus 2. So if we rewrite this, it's easier to use rational exponents. So we have the inside stuff to the 1/3 power. Okay. So if we use the generalized power rule formula, that 1/3 is going to come down, and then we're going to put the inside junk in, and then we're going to subtract 1 from the exponent, multiplied by the derivative of the inside. So that's what's happening using the chain rule. 1/3 comes down, junk inside, and then subtract 1 from the exponent. So instead of 1/3, it'll be negative 2/3 when we subtract 1 from it. Derivative of the inside stuff is 2x minus 4. And then just rewriting that, so the 2x minus 4 is going to hang out on top. 3 times cube root of the inside stuff, quantity squared. Okay. So it'll be derivative of the outside with the inside still preserved, and then times the derivative of the inside. So let's take a look at another example. X over square root of x to the 4th plus 4. We can rewrite this as x and then x to the 4th plus 4 to the negative 1/2. So we got two things going on here. We got a product of functions, x and then that other stuff. So we're going to have to follow the product rule, and then as part of the product rule, we're going to use the quotient rule embedded in with it. Okay. So it'll be derivative of the first times the second function, plus the first function times the derivative of the second function. Now the second function is x to the 4th plus 4. Minus 1/2 comes down. Inside stuff is the same. Subtract 1 from the exponent, and then we need to multiply the derivative of the inside. Alright? So you're done with calculus right there. The rest of this is all pre-cal or algebra stuff right here. We're going to factor out the lowest power of the x to the 4th plus 4, which is x to the 4th plus 4 to the negative 3/2. So we're going to factor that out, and we're left with x to the 4th plus 4 to the first power, and then we have negative 1/2 times 4 gives us a negative 2, and then we have an x to the 4th left over. Let's go ahead and combine like terms. So we have negative x to the 4th plus 4 divided by square root of x to the 4th plus 4, all raised to the 3rd power. So it's a combination of product and chain rules here. Moving on, we have g of x is equal to 3x minus 2 over 2x minus 3 squared. Now one way you could do that is you could FOIL out the numerator and denominator, and you have a big quotient to take care of, and it'd probably be quite a bit of mess. It's going to be messy either way if we use the chain rule. But if we use the chain rule, you have the outside function is x squared, so the 2 is going to come down, the inside's going to stay the same, and then the power is going to change from a 2 to a 1 because we subtract 1. Then times the derivative of the inside stuff. Now the derivative of the inside stuff is a quotient, so we're going to have to use the quotient rule. So it is still kind of messy. So the 2 comes down, and then it's the inside stuff to the first power, and then we got to use the quotient rule. So low d high minus high d low all over low squared. So we're done with calculus. Everything else is just packaging your answer nicely with some algebra. So 2's hanging out, 3x squared minus 2. I think I forgot the square there. I might need to go put that in there. So all of this is just a bunch of algebra. I did some distributive property, and I combined some like terms, and I think I can add in that square that I forgot. Let's see what else did I do. Okay. So mostly just a bunch of algebra. I forgot the square here, so I'm going to try to put in a square here. It didn't change anything. I just forgot to write it in. So what happened is we distributed that 6x, distributed that 2. That's how we got to this next step here. And then we combined like terms. So 12x squared minus 6x squared is 6x squared. 18x and a positive 4. And then the last thing we did is, remember that 2 was hanging out in front. I see 6, 18, and 4 all have a GCF of 2, so that 2 comes out and multiplies the existing 2 by 2 and gives us 4. I'm okay with this answer. This one's good too. The final one's good too. But if you got to this step here, that's fine. All right, let's get all this yellow stuff out of the way, and we'll move on to the next one. So y equals sine pi x. All right. So outside function is sine. Inside function is pi x. Derivative of sine is cosine times pi x of pi x. Excuse me. And then the derivative of pi x is just pi. Okay, let's put that pi in front. Pi cosine pi x. Okay. Now if we look at another one, some GV function, like cosine v over cosecant v, we can rewrite this instead of writing the cosine, or I'm sorry, the cosecant of v, we could write that as 1 over sine v, cosine v, sine v. And right now, do I need to really use the chain rule? Probably not. It looks like just a product of two functions. So it's going to be the first. Well, let's see. I did derivative of the first, which is fine. Derivative of the first times the second function plus the first function times the derivative of the second function. So sine squared minus cosine squared minus sine squared of v is a double angle formula, so it gives us cosine of 2v. Now, if we wanted to take the derivative of that again, it would probably be easier to use this and the chain rule than it would be for cosine squared v plus sine squared v. All right. How about h of t equals 2 cotangent pi t minus 1. That 2 is just a constant. It's going to hang out. We're going to have to use the chain rule twice, because the first outside function is we have the square function. Then we have an inside function, the cotangent, and inside the cotangent we have pi t minus 1. So we actually have 3 functions going on here, so we're going to have to use the chain rule twice. H prime of t is equal to 2, okay, and that's using the power rule. The 2 is coming down from the cotangent squared, okay, times cotangent pi t minus 1, and that's the first power. Okay, so that cotangent of pi t minus 1 was squared. The 2 came down. Now we're applying the chain rule, and we have to take the derivative of cotangent pi t minus 1. So the derivative of cotangent is negative cosecant squared of pi t minus 1. And then we have to take the derivative of the inside piece, which is pi t minus 1, which will just give us pi. So repackaging that, the negative comes out. 2 times 2 is 4. There's the pi. Cotangent t minus 1, cosecant squared, pi t minus 1. So we had to apply the chain rule twice in this this problem because it was a composition of three functions. How about y equals sine cube root of x plus cube root of sine x? Get rid of the radicals and write it in rational form. So x to the negative 1/3 plus sine to the 1/3. Okay. So we have two functions on the first piece. Yet the outside function is sine and the inside function is x to the 1/3. Outside function's derivative, the outside function is sine, so the derivative is cosine, evaluated at the inside, times the derivative of the inside. So the derivative of the x to the 1/3 is 1/3 x to the minus 2/3. Okay, and then the second part, let's see if that'll come back. The second part is the outside function is the 1/3 power, the inside function is sine of x. 1/3 comes down, sine of x, subtract 1 from the exponent, and then the derivative of sine is cosine. I think I lost a addition sign here, so there should be a plus there. Let's see, how can we rewrite this? Well, we can write it as cosine cube root of x over 3 cube root of x squared for that first piece. The second piece will be cosine x divided by 3 times cube root of sine x squared. So, just a little bit of application of chain rule, and I think I have one more for you. So we would like to find the second derivative of f of x equals 1 over x plus 4 in the square root. And then we would like to evaluate it at the point 0, 1/4. To write it a little bit more friendly, we're going to write it in rational notation. When we take the derivative, we're going to have to use the chain rule. So the negative 1/2 comes down, x plus 4, subtract 1 from the exponent, negative 3/2. Okay? The derivative of the x plus 4 is just 1, so that's not going to add anything too exciting. If we want to take the second derivative, the negative 3/2 is going to come down. So we'll have negative 1/2 times negative 3/2 times x plus 4, subtract 1 from the exponent, negative 5/2. And then the derivative of the inside piece, the x plus 4, is again 1. So repackaging this will be 3 over 4. And then I'm going to go ahead and evaluate it too at 0. So get 3 over 4 times 32, which would be 4 to the negative 5/2 power. So at 0, the second derivative is 3 over 128. And later the second derivative is going to tell us something about the concavity, the rate of change of the rate of change. And later on, if we have a positive second derivative, that's going to tell us that we have concave out.